Hello and welcome back to Coding Physics with Spreadsheets. Last time we looked at how we could use a spreadsheet as a calculator. This time I want to look at how we can use a spreadsheet to predict what's going to happen to a moving object. Here's what I want to do. Last time we used this distance formula, right? Distance equals velocity times time. And that's somewhat useful. That's only really useful if this time that you have is the time since the beginning of when you started measuring. What I want to do instead, I'm going to add in a column here. So I'm going to right click on here. I'm going to say insert one to the left. And instead of getting the total distance here, I want the distance moved in the previous step. And that is a long name, so let me turn on the text wrapping. There we go. When I say step, what I mean is going from time t equal to 0.1 to time t equal to 0.2, from 0.2 to 0.3, 0.3 to 0.4. So each one of these cells is a step. In fact, maybe I should just call it previous cell. There we go. The way I'm going to get that is first I need to get the amount of time that transpired, right? So I'm going to take this time, the current time, minus the previous time. So I'm taking A3 minus A2. I'm going to put those in parentheses because this right here, this is my delta t. This is how much time has elapsed since the last cell. Now I'm going to multiply that by the velocity. So this is velocity times time. So that'll give me a distance, right? It's the distance I moved in the previous cell. Now I fill this in, I get the same amount each time. That's because I have the same time interval in between each of these. I'm going up by 0.1 seconds each time, and I have the same velocity in each of these. We're going to change that in a minute to make it a little more interesting, but for right now, these are all the same. So now this distance, we're going to start this off with 0. And what I'm going to do here, I want to add to this. So I'm going to take this current value, and I'm going to add to it the distance that I moved. So in that first cell, I moved 0.15. In the second cell, I moved another 0.15, but that took me from 0.15 to 0.3. In the next cell, I moved from 0.3 to 0.45. And on we go. Each of these is going to increase by 0.15, the same amount. And you look over here and you say, okay, my position versus time graph doesn't look any different, right? It's still going up with a positive slope. If I were to get the velocity off of this graph, I would get a velocity of 1.5 meters per second. Here is the interesting part. I'm going to make a slight adjustment to this graph here. We're going to take this vertical axis and we're going to set its minimum value to be -3 and its maximum value to be 3. Okay, there we go. Because I don't want those shifting around on me when we make some changes to this thing. Here's what we're going to do. We're going to set this velocity. We want this velocity to be constant. So here's what we're going to do. We're just going to say that velocity equals the velocity that you had before. Again, there's not a huge change to that, but there will be in a moment. Okay, so here I'm moving at 1.5 meters per second. What I'd like to do now is change this to 1 meter per second. Now watch what happens. Because all of these have been set equal to the previous one, they all turn into 1s. But I want you to notice what happens with the graph here. The graph gets shallower because I've got a smaller velocity. So I'm moving a smaller distance in between cells. So I end up with a shallower slope for this distance, for this position versus time graph. And actually this should be labeled position. There we go. And I could change this, for example, to 2. I could get this much steeper than it was before. I could change it to 5, make it even more steep. In fact, it's going off the graph now. I can also change this to a negative value. You know what negative velocity means, right? It means I move backwards, right? So I move with a negative slope. The other nice thing about this is I can change my initial position. So this is assuming I start at initial position of 0. Watch what happens when I change this initial position to 1. Everybody gets moved up. The graph gets moved up because I have to start at 1 here. Now let's suppose I start at 3. Where do you think it's going to move to? The graph moves all the way to the top here because this is my starting point and this is my speed. This is the y-intercept. This is the slope. Velocity works exactly the same way slope does because it's just a linear relationship. Okay, let's get back to 1 meter per second. And let's start at a -2 meters. So that way I've got this thing pretty well in the frame. Watch what happens if I decide I need to walk faster. Let's suppose I've been walking for an entire second here, and I decide I need to start running to catch up to somebody. So let's change this to a 2, right? So I'm going to manually change this one to a 2. All the others below it are going to change to 2. Look at what happens to that slope at 1 second. Here I've got one slope. Here I've got a faster slope. I've got a sudden change in my velocity. And so this spreadsheet is able to help me model and predict what happens when I change my velocity. This is allowing me to visualize what's going on in my velocity graph. I go from a lower slope here to a higher slope over here. I can even increase my speed later on if I want to, right? I could change my speed to 3 near the very end. And so over here, I've got another increase in my speed. I'm going from 1 to 2 to 3 for my velocity. And this is pretty neat because this is how we operate in the real world, right? We tend to run at a constant velocity and then we need to speed up and then we maybe need to speed up more. Or maybe we decide we need to turn around and go back, right? Maybe I could change this to a -1. And suddenly I realize I left something behind, so I need to turn around and head back to my house. This is actually a useful way to model this because when you have something with a changing velocity, like when you have a car that's starting to move faster, that's accelerating, we need to be able to change the velocity for each one of these. And that's what we'll look at next time when we look at coding acceleration.